One of the main topics in forecasting is the topic of accuracy, of how good is your forecast. Um, you can imagine the conversations around this concept, right? You can forecast all you want, but are you accurate? Are you predicting what actually ends up happening? Which probably you're not, because it's extremely difficult. But how accurate are you? That's really a more interesting question, because we can measure how accurate someone is with his or her forecasts. So we go back to the example with the gasoline sales. So we have 12 weeks, we have 12 observations here, and we want to forecast. We want to forecast next week, next month, next year, in this case, next week. We're going to apply a what we call the naive forecast method, which is pretty simple, doesn't require much. Mathematically, it's pretty simple. And it's as follows. Under the naive forecasting method, all you're going to do is you're going to take the observation in the current period and you're going to apply it to the next period as your forecast. So if in week 1 you sell 17, your forecast is that you will sell 17 again on the next period. So, and so on and so forth. Now, let's see how this works. We move to week 2. Actual sales are 21,021. That means that we're going to forecast for week 3, 21, same as week 2. So you see what we're doing here is we're taking actuals and we're using the actuals as forecast for the next period. Week 3, actual 19. We're going to forecast that for week 4, it's going to be 19 as well. But as you can see, every time I forecast, right, your eyes go back to, okay, I forecasted 17 for week 2, but I ended up being 21, the actual. Forecasted 21 for week 3, ended up being 19. So I'm not getting it right. That's clear. I mean, clearly I'm not getting it 100% right. But how close am I? That's what we're going to look at in the following columns. Okay, but you keep doing that. One interesting observation here that you need to keep in mind, especially at the very end, is that even though you have 12 weeks, you only have 11 forecasts. That's because the first week, you don't have a forecast for the first week. The first week is the first week, is the actual. Okay, keep that in mind. So let's look at the different methods to measure accuracy. So the easiest one that you probably already figure out is to look at the forecast error. Forecast error, which is simple. It's just going to be my forecasted value minus, the actual value minus the forecasted value. Okay, so I'm going to build a column right here. And class, this goes back to many of the comments that I had on your exams and many of the interactions that we had. You need to be organized with your data. In many cases, I told you specifically to build a very specific table, and some of you just didn't do it. And you got lost, you probably spent a lot of time. No, build a table consistently every single time, and it'll make your life so much easier. At the very least, you're going to save a lot of time. Okay, so look, forecasted error is going to be actual minus forecast value. Now I know why I didn't have error there, because it doesn't belong there, because this is my error. Sorry about that. Okay, actual minus forecast, which is C4 minus D4 equals 4. As you can see, this is so easy when you have a table, because imagine, you're at this point, right? Look at how the numbers change, right? You're here, you do the first one, you double click on the little corner here, all done, right? Now, problem with a forecast error, right, is that Well, it is a problem and it's not a problem. You just need to understand what the math is doing here. A +4 and a -2 gives you magnitude and direction, right? It tells you that you went 4 below in this case. So a positive is that I was 4,000, whatever that is, 4 away from the true answer, and -2 is that I overshot it by 2. You're probably thinking that's counterintuitive because it should be the other way around, but that's just the math, the way it worked with this, which by the way is not going to matter in just a second. But you do that, right? So you're like, under forecast, over forecast, you overshoot it, you undershoot it, back and forth, back and forth, back and forth. So if someone asks you, well, how good are you in general? Okay. If you add up all of these numbers, right? You think, well, if I add up my errors, that will give me an idea of my error. So let's do it here. The sum of all these errors, it's 5. So it would appear that you're pretty good at forecasting because you only made an error of 5. Well, but that's not quite completely true, is it? The total amount of your error is far more than 5. It's just that kind of like on average, you were around that, that 5, up and down, up and down, up and down. So we need context. That's just, it's kind of misleading. So what we do in column F, we use a technique called absolute, which you might remember from your days in high school or college. And the formula is very simple. I have them up here so you can see it, but also if you click on the cells, you see it here as well. It's equal ABS of E4. Okay? So what I'm doing is I'm taking the absolute number, the absolute value of each of those numbers, which all it does is basically it just removes the negative sign in front of each number. You see that? That's all it does. Now, if I add up all of those numbers combined together, now I get 41. That's actually the value of my entire error. If you add up all my overshooting and undershooting, overcasted, undercast, the value is 41. Well, what a difference, right? That's a huge difference. Apparently, I'm not as accurate as I thought I was. Another technique, these two techniques are actually very similar. They lead you to different places in statistics and econometrics and so on. But another way of fixing the issue with with the negative signs is to take just square each of the observations. So you're going to take, actually, this is incorrect. It should be, sorry. Why? Okay, I'll tell you what. I don't know why it's not cooperating. All right. What I'm doing is I'm just doing the square of each of the observations. By doing the square of the observations, you're actually getting rid of the negative sign. You're also magnifying every error times itself. So you get 179, which doesn't mean much like this. This number the 41 is a much better number than the 179, but this can be used for something else later. Okay. Again, you just build your table and go along with it. So, calculating errors this way, how many dollars you were above, how many dollars you were below, might work, but in many cases it does not work because the magnitude of the numbers is kind of masked. This is what I'm trying to say. If your error was 41 total in sales, I don't know, of cookies, if you're selling cookies and lemonade, if you have a lemonade stand and you're selling lemonade and you your error is 41, I think you messed up big time. I think you way overestimated your lemonade and you are going to be dragging home a lot of lemonade because you're not going to sell it. But if 41 is 41, let's say it's $41 out of forecasting sales of cars for Ford Motor Company or Cadillac, if you only made a $41 mistake in a multi-billion-dollar sale, I think you're pretty good. I think you're, amazing actually. Clearly, it's never going to be that close. So the one number that we can compare, regardless of the magnitude of the underlying measure that we're trying to take, the underlying product, the underlying activity, service, whatever that is, if you do it on a percentage basis, now you can compare your accuracy across multiple projects, multiple jobs, multiple divisions, multiple businesses, etc. To do that, you're going to take column E, okay, which is that, your forecasted error, and you're going to divide it by how much the actual was at the time. So E4 divided by C4, 19. That means that you were 19% off. You're going to do it to each of the observations in the forecast. So negative 0.5, etc., 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 etc. So on average, you were 1.19% off. That's a more valuable metric than any of this, because now you can compare this to other things, as I previously mentioned. But just like we mentioned before, you have this issue of the negatives and the positives that you're bouncing around. Okay, I mean, imagine if your forecast is always either one above or one below a specific number, the average would be zero error, right? Because if you're always either one up or one down, one up, one down, one up, one down, the average is zero error if you do this type of formulation. And that's not true. You made errors. As a matter of fact, you made an error, an absolute error of one in every single period. It's just that sometimes you were above the line, sometimes you were below the line. So we're going to take care of that, right? So the way to do it is we're going to take each of those numbers. We're going to find the absolute number, which is basically the same we did on this column, on column F. We're going to find the absolute of each of the percentage errors, and then we're going to add it together, and we're going to get 211.7%, which is obviously not as good as 1.19, right? This is atrocious. As a summary of your forecast, we have 4 metrics, pretty standard in the business. These are very standard in the business, used for different purposes. Everyone has a particular one that they like. Personally, they go. I will rank them the way they're here in importance, but in descending importance. This one being the least, this one being the most. So we have the first one is MFE, which is the mean forecast error. Simple. You're going to take the sum of the forecasted errors, and you're going to divide it by the number of observations. 11. Remember, that's what I mentioned. I think it was the first thing, not the first thing, but one of the first things I mentioned. You only have 11 forecasts, even though you have 12 observations. If you look at your problem, the textbook, the text will talk about it, is your K, just reminding you that the number of observations and the number of forecasts, that's not the same. There's always going to be one less than the number of observations. So it's not 12, it's 11. So I take the forecast error, I divide it by 11. Now I have a percentage of the, I have the mean of the forecast error. I can do the same with the absolute error. I can take the absolute error divided by 11, and now I have an even better measure, 3.73. Now I'm looking at the average of the absolute errors. Then I can take the mean square. Another option is to take the mean of the square errors, which probably you already figured out. Is going to be the sum of all the square errors here, which is 179, divided by 11. Make sure that I didn't. Yep. And finally, which is the most important one, this one is the one that it's mathematically makes perfect sense, mathematically, you can use this and compare to any other particular activity, project, you name it. It's a good measure. This is the mean of the absolute percentage errors. And the way you do it is you're going to take the sum of the absolute percentage values that you calculated here in I, and you're going to divide it by 11. That's all it is. And now you have 19.2%, which is mean absolute percentage error. And this is one that you can compare without a doubt. It's very, very robust. The others, you can compare them across multiple projects, multiple activities, but the mean absolute percentage error, let's call it, is the most sophisticated and the one that gets you farther and farther away from the problems of estimating errors in forecasting.